pressure. We know pressure, we said pressure is equal to what? Force over area. So we have to look for the force in relation to the molecules of the gases inside the system, as well as the area in relation to the body of the system. So the force in relation to the molecule of system has to do with the momentum of this body of the molecules of the system. So we said we want to say our force is equal to our change in momentum over change in time. That's our force. Change in momentum over change in time. That's how well do they move within a particular system in relation to time. That is that. And our area is equal to what? L square, which is the area of a square. So how are we going to get our change in momentum? Change in momentum is the same thing as mass times velocity. So we have change in momentum to give us the product of mass, or momentum to give us product of mass times velocity. Now, if the particle moves in one direction, let's say in the x direction, change in momentum becomes mu. Now, the particle comes back, that's the final momentum. This is the initial momentum, ix. The final momentum gives us fx, becomes minus mu. So you see, when the particle moves towards the wall of the container, we have mu in x direction. That is why I'm using u. Now, when the particle comes back, it becomes what? Minus mu. So change in momentum gives us the initial momentum minus the final momentum. Now, what is the initial momentum? Mu. What is the final momentum? Minus mu. So automatically we have mu plus mu, which will give us what? 2mu. 2mu. So the change in momentum is what? 2mu. Now, what about the time? We know that velocity u is equal to what? Distance 2l over change in time. Why I'm using 2l is that the first length is the one the particle uses to go to the wall of the container, which is l, and the second length is the one it uses to come back, which is another l. So l plus l gives us 2l. That is that. So velocity is equal to distance over time. So from here we can get time, change in t, to become what? Distance over velocity. So automatically now, for our force, we already have change in momentum and change in time. So we can put these two formulas into this our force here. So we'll get it that our force is equal to change in momentum over change in time. What is our change in momentum? 2mu. 2mu over, what's our change in time? 2l over u. So we have it as 2mu divided by 2l over u. Same thing as 2mu times u over 2l. When you change the division sign to multiplication, you reciprocate this other term. I have it in one of my videos, so if you don't understand, you can easily check. Maybe in most of my calculations, you'll be seeing me reciprocating this thing. So that's how you do it. When you want to change the division, I use division because it's 2mu divided by, that's why I use divided by here, 2l over u, which is that term there. So if you change division to multiplication, you reciprocate this one. Take the denominator to the numerator. I have a video on denominator and numerator if you don't understand what I meant, as well as fraction. So you just check my videos on my playlist, you'll be able to see it and to follow. So these two will go off with these two. Now u times u gives us what? U square. So we have it as u square. Our m is there over what? L. So automatically our force gives us what? Mu square over L, which is our force. Now remember, our force now is mu square over L, and we are looking for our pressure, which is the division of force over area. So we have to put this mu square over L into this place to give us our pressure. Pressure is the one we're looking for. Pressure is what we are going to calculate, because as the molecules collide, causing pressure, then what can be done, which is thermodynamics, movement of heat. So movement of heat is as a result of the collision of the molecules within the particular system. So when a molecule gains internal energy and moves, when it hits another molecule, it transfers the energy. No, the first law of thermodynamics says that energy can never be created nor destroyed, but can be transferred from one form to another. So when the molecules gain kinetic energy and move to an excited state, they tend to move. They are excited. So as excited, it hits another molecule which is not excited, and that molecule tends to move. You can easily see it when you throw two balls. Maybe a ball is static. a ball, you have a ball that is static and you have a moving ball coming. Now automatically when this moving ball hits this one at ground state, automatically it must be excited, it must move. So that is transfer of energy. That's what thermodynamics says. So if we put this force into this particular formula, we have pressure is equal to mu squared over L, then divided by our area. What's our area? L squared. So pressure is equal to mu squared over L times what? 1 over L squared. So pressure is equal to mu squared over L cube. And we all know our L cube is equal to what? Our volume. So pressure is equal to mu squared over our volume. Now, this is for one molecule. What if you have more than one molecule? We introduce the constant n, mu squared over our volume. Now, this n now signifies the number of molecules. So if you have 100 molecules, then you use 100 times whatever. If you have one molecule, it becomes one time, or that is that. Now, so we said u is for one particular direction. What if we have the three directions? Automatically, our u becomes what? Our c squared over 3 for the three directions. So if we put that into our formula, we have nmc squared over 3v. So this gives us the pressure in all directions, the pressure of the molecules in all directions. That is that. So the next is our specific volume. Specific volume is the same thing as saying our volume per unit mass. Now, if we say the kinetic energy, which is the energy as a result of the motion of the particles, is directly proportional to the temperature. So if you increase the temperature, increase the heat, increase the temperature of the particular system, the energy of the molecules will increase, and if you reduce the temperature, energy of the molecules will decrease. So we have that kinetic energy is proportional to temperature. Remember, kinetic energy we said is what? Half mc squared. From that other one, half mc squared is proportional to temperature. So if we remove this proportionality sign, we introduce a constant k. So we have half mc squared is equal to kt. That is that. Now remember, we have mc squared here and mc squared here. So if we were to make mc squared here the solid of the formula, we have it as cross multiply this one, we have this 3v multiply p, we have 3pv is equal to this nmc squared multiply this one, we have nmc squared. So we are left with that. So if we want to remove this n here, make n, remove this n here, we are left with what? mc squared. So we have mc squared is equal to 3pv over n. And we have mc squared, so we can replace this mc squared here with this mc squared here to give us half 3pv over n. 3pv over n is equal to kt. So we have, if we want to now cross multiply here, we have 3pv over 2n is equal to kt. So when we cross multiply, we'll leave pv here. We have pv or 3pv is equal to 2n kt. So divide through by 3, we have pv is equal to 2 over 3 n kt. Also, from the ideal gas equation, we know that PV is equal to what? RT. PV is equal to RT, or we have N RT, depends on that. So if we have PV is equal to RT, PV is equal to 2 over 3 NKT, which means that our RT is equal to what? 2 over 3 NKT. That means our ideal gas equation becomes what? 2 over 3. When this T goes off with this T, 2 over 3 nk. So what it means is, if we have the constant and we have the number of molecules, if we have them multiplied to each other, it gives us the ideal gas equation. So the last is the compressibility factor. Compressibility factor will now give us, from this equation here, PV is equal to RT. So compressibility factor is when we divide through by RT. This goes off with this. We have introduced the constant Z. So our Z is equal to PV over RT, which is our compressibility factor. Now, somebody may ask us, what is specific volume? Specific volume is simply the volume over the mass. Remember, the number of molecules is equal to what? Mass over molar mass. So we have that the number of molecules N is equal to mass over molar mass. So if we replace that number of molecules N is equal to mass over molar mass into this our formula here, we have this. 3PV is equal to 2N KT. So we have 3PV is equal to 2 mass over molar mass KT. So if we divide through by mass, we have 3PV over mass is equal to 2 KT over molar mass. So this becomes our specific volume, which is 3P specific volume is equal to 2 KT over mass.